In this video, we will step through the deployment of a containerized application on Amazon ECS using CloudFormation and CLI. This is not an introduction to ECS or containerization or even CloudFormation. If you have not used CloudFormation before, I suggest you watch episode 7. Besides the basics of CloudFormation, you will need to have the basic knowledge of Docker, Docker registry, creating or building Docker images, etc. Let's take a look at the steps that we are going to go through in this video. We are going to start by creating a simple API application, create or build Docker image for that application, and test it locally. Using AWS CLI, create a repository for our Docker image on ECR or AWS ECR, and push the Docker image into that registry. Next, we will define a CloudFormation stack to define a VPC, 2 subnets across 2 of the availability zones on an AWS region. Creating VPC and subnets will also involve defining things like internet gateway, route tables, and so on. Next, we will define a CloudFormation stack to create resources such as ECS Cluster, application load balancer listener for port 80, CloudWatch log group for the containers, and a couple of security groups. And then define a CloudFormation stack to create task that configures the container, and then create a scheduling service that runs the container or the task, and define deployment configurations, configure the container logs and load balancer rules, and so on. Configure it in a way that on launching the task instances or container instances, it will fetch the image from ECR and it will register the container onto the load balancer, and also have the container logs go out to CloudWatch log group. That's a lot of things to cover in a short video. I'll try to adjust the pace to not drag this too long. So let's get started. I'm going to be using the AWS CLI to create or delete stacks on AWS instead of the AWS Management Console. Let's go to the terminal window, create a project directory. I will name the directory as Docker on ECS and go into that directory. Let's open that in a code editor. I'll start by creating a tiny API application that we then containerize or Dockerize. Create an app directory, and I'll create a service, name it as service.rb. This is a simple Ruby service in a few lines using Sinatra framework. I will paste in some code here. As I said, it's a Sinatra app, so it needs to require those libraries. Here is a simple data model book that defines a static list of books, each with an ID and name attributes, and 2 class methods, one that returns a list of books and another one that does a book lookup by book ID. Here are the 2 default and health check URI paths for this service. Both return a simple text response with 200 response code. Here is the namespace for API endpoints. Let's say all of our API endpoint or URI paths start with /API. Here it sets the default content type as JSON and defines 2 endpoints here. One that returns a list of all the books as a JSON response, and another one that returns a book by book ID in the URI path. That's how simple the API implementation with stub data is. So I have copied the following files, Docker file to define Docker image for this simple application, and other 2 files, gemfile and gemfile lock for the Ruby application. So let's not go into the details of those files. Let's build the Docker image locally. Command is docker build tag books API and the directory of the Docker file app. In a few seconds, we had the Docker image created and tagged as books API :latest. Now let's run this container application locally and test it. Command is docker run with some options. The Sinatra app runs on port 4567 in the container, and let's expose that on the same port on the host as well. So the port mapping is 4567 on both container and host. An option to remove the container after the container is stopped, and the image name, books API latest, which is on local. Here we have the application running in container and available on container port 4567 and is the same port on the host as well. Let's go to the browser and test request localhost 4567, which is the default health check endpoint, which responds with a text message. That looks good. Now request the API for listing the books, localhost 4567/API/books. And that returns a list of stubbed books as JSON. That looks good. Let's stop the container, and now we need to push the Docker image to a registry, Amazon ECR. On another terminal window, let's create a new repository on ECR for our books API image. I have the AWS CLI configured with a default profile. create a repository now. Command is AWS ECR create repository, repository name Books API for our Docker image, and submit. Repository on ECR has been created and we have the details here. Now let's log into the Docker registry or ECR, for which we will need login credentials. With ECR, we can get the login or Docker login command using CLI, and the command is AWS ECR get login with some options. This will return Docker login command to ECR with an inline password. So I will pipe the output to a shell, and that runs the Docker login command. Now here, the Docker login to ECR is successful. That's good. Now let's push the image to the repository on ECR. We need the repository URL, which was in the response of create repository command. Let's get that using ECR describe repositories command. AWS ECR describe repositories, repository name is Books API, and here is the repository URI. Let's copy that. We will append the repository URI with an image tag, say v1. Now tag Books API latest image on local as the repository URI :v1. And the command is docker tag Books API latest, paste in the repository URI :v1. Now let's push the image to ECR. The command is docker push repository URI :v1, submit. While the image is being pushed, let's verify the repository on AWS Management Console. Under Services, go to Elastic Container Service, and on the left-hand navigation, go to Repositories. Here is the Books API repository we created from CLI. Switch back to the terminal window. Now the image has been pushed to the repository. Let's verify that on the Management Console. Click on Books API repository, and here is the image tag v1. Now let's start creating CloudFormation stacks to define the infrastructure and resources to run the container application on ECS. Let's define a CloudFormation stack template to create VPC, subnets, and resources to define internet gateway and route tables, etc. I will create a new directory called infra. Under that directory, let's create a stack file. I'll name it as vpc.yaml. Let's define the stack template version and some description for the stack, VPC for ECS test, and now define the resources. There are mainly 3 resources in this stack. One is the VPC and 2 subnets, subnet 1 and subnet 2. For VPC, the type is AWS EC2 VPC, and the properties, to make it quicker, I'll paste in some properties here. CIDR block that defines the IP range available within the VPC, enabled DNS support to set to true, enabled DNS hostname to true. With this, the instances launched within the VPC gets hostnames, and instance tenancy is default. Now let's define subnet 1. The type is AWS EC2 subnet, and let's add some properties. VPC ID is the VPC defined above, which is the VPC this subnet will belong to. We can use ref function to refer to the VPC resource defined in the same stack. We need to specify the availability zone for this subnet. The default region that the CLI profile is configured to is US West 2, and that region has 3 availability zones, and we need to pick the first one for this subnet. One option is to use the hard-coded zone name, and another option is to use predefined functions to fetch a list of availability zones and pick the first one. We will go with the latter. Use the function getAZs that returns all the availability zones, and use another function that selects the first one or the one at index 0. CIDR block for the subnet within the VPC. Set map public IP on launch to true. With this, the instances launched within the subnet will have a public IP address. Now that's all for the subnet 1. Let's define subnet 2. Copy subnet 1 properties and paste in for subnet 2 as well. Couple of things we need to change for subnet 2. Pick a different CIDR block within VPC and change the availability zone to set the second availability zone or the one at index 1. That's it. Both the subnets have been defined. Now, in order to allow internet connection to the VPC or resources within VPC or subnets, we need to create internet gateway, route tables, and associate them to both the subnets. Let's create an internet gateway. I'll paste in 2 lines of code for this resource. Resource type is AWS EC2 Internet Gateway. Now, we need to attach this internet gateway to the VPC, create another resource, which is of type AWS EC2 VPC Gateway Attachment. And the properties are Internet Gateway ID references to the Internet Gateway defined above, and the VPC ID, which references to the VPC defined in the same stack. Internet gateway has been attached, and now we need to create a route table within this VPC. Here it is. The type is AWS EC2 route table. Only one property, VPC ID, which refers to the resource VPC. Now let's associate the route table to both the subnets. For subnet 1, create a subnet 1 route table association. Name it as route table association 1. Type is AWS EC2 subnet route table association. First property is the subnet, which references to the subnet 1 that's defined above, and second property is the route table ID that references to the route table resource defined above. Repeat the same to associate subnet 2 to the route table. Here it is, route table association 2. Subnet ID references to the subnet 2 resource. Route table ID references to the common route table resource. Now, one last thing in the VPC stack, and that is we need to define or create an internet route that links the internet gateway route table and defines destination address to allow the connections. Here it is. Type is AWS EC2 route, depends on the creation of VPC gateway attachment we defined above. This means the internet gateway and VPC attachment is complete before this resource is created. Gateway ID references to the internet gateway defined above. Route table ID references to the route table defined above. And lastly, the destination CIDR block for this route, easier one, is 0000/0. That's all the resources we needed to define in this stack. I'll have to keep the detailed explanation of VPC, subnets, route tables, route gateway, etc. out of the scope of this video, as that itself is a separate topic and will require a good amount of time. Now that we have all the resources defined, let's output some of the resource identifiers that we need to refer in the stacks we are going to create next. First output is VPC. Give it a description, which is optional. Value of the VPC can be fetched by referencing the VPC resource defined above. Export as a variable that it can be referenced in another stack. Give the variable a name. I'll name it as VPC. Now one more output is subnet 1. Give it a description. Value is a reference to subnet 1. Export variable subnet 1. Let's repeat the subnet output for subnet 2 as well. That's all for this stack. We have defined a VPC, 2 subnets, one each on 2 of the availability zones. Internet gateway, attached that to the VPC route table and associated the route table to both the subnets. Internet route that links gateway, route table, and destination address range. And finally, output the VPC and both subnets to be referenced in the stacks we are going to create later. Switch back to the terminal window and execute a command to create the stack on AWS. The command is AWS CloudFormation create stack, stack name. I'll name it as VPC. And the CloudFormation template body, file, the current working directory, /infra/vpc.yaml. Now before I execute this command, let's review the template one more time for any typos or errors. Here's one. This should be outputs, plural. And for both the subnets, I need to move the properties under properties tag. Let's do that. And that looks good. Under the outputs, again, subnet 1 is repeated, and the second one should be subnet 2. This is good. Now let's go ahead and run the command. The command is successful. Stack is being created, and we have the stack ID in the response. Let's go to the management console and go to services, CloudFormation, and there is the stack VPC, which is being created. A few seconds fast forward, we have the stack created. Now let's go to the outputs tab, and here we have the outputs from the stack creation. These are the 3 outputs we have defined: VPC, subnet 1, and subnet 2. Export name is what we will be using to reference these resources from the stack in the stacks we are going to create next. Now, before we create other stacks, let's create one more stack that will define IAM roles, or identity and access management role, that we need for the containers to be able to interact with CloudWatch and ECR. Let's copy the VPC template and name it as iam.yaml. So let's clean this up and update the description, roles and policies. Let's create a new resource and name it as ECS task execution role, which is a role that we need to assign to a container task in ECS. We will know how that helps later when we run containers on ECS. Type is AWS IAM role, and add properties. I will paste in some code here. Let's not go into the details. At a high level, this is the role for ECS task that we will define later, and policies allow permissions to resources on ECR and CloudWatch log group from the tasks or containers. Let's also output this role so that it can be referenced in the other stack templates. I will paste in the code to output. Notice the value of the output, instead of using ref function, it uses getAt or a getAttribute function to read a specific attribute ARN from the resource ECS task execution role. And name of the export variable is ECS task execution role. And that's all for the role definition. Let's go ahead and create the stack on AWS. Command is AWS CloudFormation create stack. Stack name, I'll name it IAM, and using template, current working directory, intra IAM.yaml, submit. And it failed, saying it needs additional capabilities, and name of the capability is capability_IAM. So a stack that creates IAM roles will require this capability. And the command now is AWS CloudFormation create stack. Stack name is IAM, template IAM.yaml, and capabilities capability_IAM, all block letters. Enter, and that's good. Stack is being created, and we have the stack ID here. Let's verify that on management console. Here it is being created, and a few seconds fast forward, the stack creation is complete. Under the output tab, we have the new role ARN assigned to an export variable. The stack that we are going to define next will create ECS cluster, application load balancer listener, and CloudWatch log group for container application logs. It will also create a couple of security groups. Let's copy the VPC or IAM stack template, and I'll name this stack as appcluster.yaml. Let's clean this up and change the description. Container cluster on ECS and load balancer. Let's start adding resources. The first one is the ECS cluster. The type is AWS ECS Cluster. The only one property it'll have is the cluster name. Let's name it as bookstore. Next resource is the load balancer for our container application. The type is AWS Elastic Load Balancing v2 load balancer. This gives an idea of kind of load balancer we are using. Under properties, give it a name. I will name it as ECS services. Now I need to provide a list of subnets. We will specify both the subnets we have created, subnet 1 and subnet 2. Now these subnets are defined in the other stack VPC and available for us to reference using export output variable. We can use the function import value to reference those variables. Let's do that. Import value subnet 1 and import value subnet 2. Next is security groups. For the load balancer, you can assign one or more security groups. We don't have any security group defined yet. Let's say the name of the security group that we're going to define is load balancer security group. Let's define that resource, load balancer security group. Type is AWS EC2 security group. Under properties, give it a description or group description. Specify the VPC, reference the VPC from the other stack output variable using import value function. Security group ingress is where we need to specify a list of ingress values. We are going to use a simple one which will allow requests or connections from anywhere. The CIDR IP 0000/0 and IP protocol value is -1 to allow all protocols. Now that we have the load balancer and necessary security group, we also need to define a load balancer listener to allow connections on, say, port 80 or 443 if you need to set up HTTPS. And then that listener will have a default target group. Let's define another resource for listener. Type is AWS Elastic Load Balancing v2 listener. And this listener for the load balancer, specify the load balancer ARN, reference load balancer resource defined above. Protocol is HTTP. Port is 80, and now specify the default actions to be performed for the requests on this listener. Default action type should be forward, and that will require a default target group. For this, we need to create a dummy target group. Say the name of the default target group is default target group. Let's define the resource for that. Type is AWS Elastic Load Balancing v2 target group. I will name it as default. VPC ID referenced using import value. Protocol is HTTP. Port again is 80. Now that we have the load balancer security group listener for port 80 and default target group, when the stack is created, request on port will error out because that target group has nothing. But we still needed to create one. Now let's create a resource to create CloudWatch log group. Type is AWS logs log group. The group name is, say, APIs. Retention in days for the logs. 1 day should be good. That's all for the log group. Now let's add one last resource in the stack, and that is to define a security group for the containers that we're going to define in the next stack. Similar to how we define a security group for load balancers that allow connections from the internet, we will define a security group for containers that will allow connections from the load balancer. So resource name is container security group. The type is AWS EC2 security group. VPC ID, reference using import value. Give it a description. And under security group ingress, mention the source security group ID and reference the security group of the load balancer we created above. And the IP protocol again is -1 to allow all types of protocols. Now let's add the output section to define some export variables. First one is the cluster value, reference the ECS cluster resource, give it an export name, ECS cluster. The next is listener, give it a description, value, reference the load balancer listener created above, give it an export name, short form is listener. Next one is the container security group. Give it a description, value, reference the container security group resource defined above, give it an export name. I'll keep it same as the resource name, container security group. Last one in the outputs is the load balancer's domain name. The output name is load balancer DNS. Give it a description. Value will be the DNS name attribute from the load balancer resource. Use the get at or get attribute function to read that attribute from load balancer resource defined above. Give it an export name. I'll name it as domain name. Now that's all for this stack. Let's quickly go over the resources we have defined in the stack. ECS cluster, application load balancer, listener for port 80, security group for the load balancer, default target group for the listener, log group for the container logs, and lastly the security group for the container we're going to deploy in another stack. Let's go ahead and create the stack on AWS. Command is AWS CloudFormation create stack. I'll name it as app cluster using the template app-cluster.yaml in the infra directory. And the stack is being created. We have the stack ID here. Let's verify that on management console. Now it failed to create the stack. Let's see what the error is. Here it is. Error indicates the name given to the load balancer is not an acceptable format. Now let's go to the stack template, load balancer definition. The name specified in the load balancer has a space, which is what it was complaining about. And that makes sense as this name will be used as part of the load balancer domain name. Let's change that to use hyphen instead of space. Save it. Now let's delete the stack from the cloud. AWS CloudFormation delete stack. The stack name is app cluster. Make sure it is deleted. And now create the stack again. Fast forward a little bit and we have the stack created. Let's quickly review the outputs. And it has the listener, container security group, cluster name, and the load balancer domain name. The last stack that we are going to define and create is the one that deploys our container image from ECR repository into the ECS cluster. Let's copy the app cluster template, name it as api.yaml, clean this up and delete all the resources and outputs. Give it a description. Mainly we'll be creating 4 resources in this stack: task, service, target group for the load balancer, and a listener rule. Let's define the task, which basically defines the container. Type is AWS ECS task definition. Give it a family name, say APIs. Now family here groups multiple versions of the task definitions. I'll skip over the details of this for now, but you will need to learn to understand how it versions the task definitions, and it has a significance when you need to update the task definitions. Specify the CPU and memory requirements. Say CPU is 256 and memory is 512 meg. Now define the container. A task can have multiple containers, but we're going to use just one. Give a container a name. I'll name it as Books API. Specify the image. It is the one from the ECR repository that we created at the beginning. We will update that in a bit. Let's add port mapping. Container port is 4567. Protocol is TCP, to be very specific here. Now let's go back to the terminal to get the Docker image URL. Describe the ECR repository, AWS ECR describe repositories. Here is the repository URI and copy that. Paste that for the container image value and append it with the tag v1, which makes it a complete image tag URL. Now that we have the container defined in the task with the memory and CPU requirements, now there are 2 ways the task can be deployed to ECS. Let's take a quick look at the options. The first option is called ECS Fargate. In this, we just need to define the container, memory, and CPU requirements and some roles that's needed for the task. And then Fargate will manage the cluster and containers. And the second option is EC2. Now this is the default one. This will allow us more granular control over managing containers on specific type of EC2 instances. We have to define a bunch more resources to manage the cluster, things like EC2 instance type, create or choose from an AMI, write EC2 launch configurations, manage auto scaling of EC2 instances, and scaling policies and so on. Now, EC2 option isn't hard, but requires us to write and know a lot more things about managing the cluster. If there are specific requirements around security or compliances, or even architecture, you will probably want to go with this option. Option 1 is easier because Fargate will manage the cluster. Now, when it comes to autoscale of containers, not the EC2 instances, you will have to write code by adding additional resources to manage the autoscaling of tasks or containers. And that's common for both the options. But with EC2 option, regardless of autoscale of containers, you will still have to code for autoscale of EC2 instances also. So we are going to go with option 1 in this video. And for Fargate, there are a few specific attribute values that we need to specify in the task definition. Let's add those properties. Network mode or the Docker networking mode. This should be AWS VPC, and requires compatibilities should be Fargate. Now let's add some logging configuration to the container. Log driver is AWS logs. AWS driver specific options, log group, APIs, logs region. So this will be the region where the stack is being deployed. Use the predefined variable using the reference function to fetch the current region. And log streams prefix to stream of logs created for every container instances on the CloudWatch. I'll name it as books API. I think we are good with the task definition here. Next is the service definition. Service will define how the task or the container will be scheduled and deployed in the cluster, and also it will define how the container instances will be registered with the load balancer listener target. So let's define the service. Name of the resource is service. Type is AWS ECS service, and properties. Task definition, reference the task resource that we just defined. Cluster is where this service will be run. The one we created in the app cluster stack, reference using import value function. Launch type should be Fargate, and then desired count of containers, say 2 instances. Cluster will ensure at least 2 instances of the container or task are active. Deployment configuration to configure how many tasks to run during every deployment. Maximum percentage, I would set 200%, so during deployment it can go up to 4 tasks if the desired count was 2. Minimum healthy percentage, I would set 70%. This basically defines the minimum healthy containers running during the deployments. The next is the network configurations. AWS VPC configuration, assign public IP set to enabled, subnets for the container instance or the task or the service, subnet 1 and 2 that we created in the VPC stack, reference using import value, security groups, mention the one that we created for the containers, and that is container security group in the app cluster. Use import value function to reference. Now when the service is run, we need to have the container be registered to the load balancer. Load balancer takes container name. The container that we need to be registered to the load balancer is books API. We need to specify this because a reference task may contain multiple containers, so we need to pick the one that we need to add to the load balancer. Container port, again 4567. Target group ARN. Now this will be the target group where the container instances will be registered to be served by the listener or load balancer listener. We will not use the default or dummy target group that we created, but we need to create a new target group for our application container instances or the service. Let the resource name be target group, which we're going to define in the same stack. And that's it for the service definition. Let's define the target group resource. The type is AWS Elastic Load Balancing v2 target group. VPC ID is the VPC, reference using import value. Now port, we have to set some value here. Ideally the port should be optional for ECS containers, but it is mandatory one, so the value can be anything. Let's just say 80. Protocol is HTTP. Let's just provide a few status and health check properties for the containers that gets registered with this target group. Matcher, HTTP code healthy targets must use on responding to the health check calls. Let's use the range, say from 200 to 299. Health check intervals in seconds, say 10, or 10 seconds between health checks for an invalid target or container. Health check path. Remember, we have 2 health check paths for our container service or the application that's going to run in the container. I will use the one that is /stat. Protocol is HTTP, health check timeout seconds. Timeout for the health check requests. Healthy threshold count, say 10. The number of consecutive successful health checks that are required before an unhealthy target container is considered healthy. Target type, value of this will depend on the launch type of the service again. For Fargate, the value should be IP. Now we have the target group where the container instances gets registered, but the load balancer or the listener is not aware of the new target group yet. Now we want the requests on the load balancer that have URI path /API/books to be served by this new target group or the containers in that target group. For that, we'll need to define a listener rule. Let's define that. I'll name the rule as listener rule. Type is AWS Elastic Load Balancing B2 listener rule. We need to specify the listener under properties. Reference the listener defined in the app cluster stack. Priority say 2. Load balancing evaluates the rules by priority order, low to high. You might as well set this to 1. The conditions. Our condition is the URI path pattern comparison. Field is path pattern values, just one value, and that is to check the URI path for /API/book star or anything that follows. Specify the actions, target group ARN, reference the new target group to forward to, and hence the action type is forward. With this, the load balancer listener should forward all the requests that have the URI path /API/book star or starting with /API/book to the targets in the target group or the containers. Now that's it for the listener rule. Let's make a small change to the service to set a dependency on the listener rule so that the listener rule is created before creating the service. In this stack, we have defined the task definition for the containers, service to schedule the tasks on cluster, load balancer target group for the container instances, and a listener rule specific to our application to forward the requests to the containers. Let's add just one output. I'd like to output the API endpoint or the base endpoint or the base URI for the APIs when the stack is created. The output name is API endpoint. Give it a small description, value. I'll add this in a bit. Give it an export name, say books API endpoint. For the value, we need the domain name from the app cluster, reference using import value. Use join function, prefix domain name with http:// and the API URI path /API/books as the suffix. That's all for this stack. Back to the terminal window and create the stack. Command is AWS CloudFormation create stack. Stack name, I'll name it API using the template api.yaml. And it failed with a validation error saying listener resource is not available in the stack. Let's check that. Here we should be using import value to reference listener, which is an output export from another stack. That's fixed. Let's run the command again and it fails one more time. There is a typo in the value of type of the resource service. Let's fix that and run it again. Now the stack is being created. Let's verify that on the management console. And it is rolling back, which means it failed. Let's see what the error was. It failed to create the task, and that is because we did not specify the IAM role for this task. We need to fix that and create the stack again. First, let's delete the stack. AWS CloudFormation delete stack. Stack name is API. Verify that it is deleted. Go to the task definition and add a new property, execution role ARN. Use import value to reference the role that we created in IAM stack, and that is ECS task execution role. That's it. Let's go and run the create stack command again, and stack is being created. Let's verify that on the management console. Fast forward a little bit and we have the API stack created. From the output, copy the API endpoint value. Go to the browser and make a request to that URL, and that should respond with a list of books as JSON. You may test the request to a specific book resource by adding /book ID, and that also works. Let's quickly check the CloudWatch log group and log streams created for the containers. If the application or the container writes all the logs to standard output, all the application logs should be available in one of the log streams in the log group APIs. Now let's go to the ECS and view the cluster. Here it shows bookstore cluster, which is labeled as Fargate, and it has one service and 2 running tasks. Under the tasks tab, you can view all the containers or task instances. Now that's pretty much for this video. Let's do a quick recap. We have created a containerized API application, created an ECR repository for the Docker image of the application, created a CloudFormation stack for VPC, created another CloudFormation stack to define IAM role for the ECS tasks to allow access to CloudWatch and ECR, created CloudFormation stack to define cluster, load balancer, CloudWatch log group, and necessary security groups. Lastly, created a CloudFormation stack to define task and service along with listener rule and load balancer target group together to deploy the container application on ECS. Before I finish up, I'd like to give a few pointers. First one is that I chose to group resources into different stacks for multiple reasons, and I have used output or variables to refer to the resources between stack templates or different stacks. Now, such approach of using output variables may not work for all use cases. Another option is to use stack template parameters. If there are multiple VPC or clusters, etc. for different API or service groups or say product groups, you cannot reuse the variables in the same region. In such cases, if you still prefer to use the export variables, you'll need to have some sort of a naming conventions for the output variables. If I need to deploy one or more APIs to be served on the same domain name or same load balancer but a different URI path, say /API/pricing, I would define a new stack similar to api.yaml and define the task, service, listener rule, and target group, etc. Once deployed, this is how it'll look from the load balancer point of view. And another option is to parameterize the api.yaml stack template. For example, Docker image, task name, URI paths, etc. can be sent as parameter to the api.yaml on creating the CloudFormation stack. And lastly, I don't consider these stack templates are production ready, but if you are starting to use ECS, I would say you can take these templates, modify, and make it work for your applications. That's all for this video. I hope this helps. Thanks for watching.